So today's lesson, what we are going to see here is lesson 6, application of derivatives. Under the application of derivatives, we are going to see the second topic, that's nothing but increasing and decreasing functions. Okay, so when do you say that a function is said to be increasing or decreasing here? Suppose I have a curve like this. Okay, so here this is the curve, and here if you see it as x1. So here the point, in this case it's a x-axis and you have the y-axis here. So this will be nothing but f of x1. So if you see the curve is said to be increasing, physically you can see that. Now here if you see in this case it is x2. Therefore you have this as, what is it here, f of x2. So here the interval is nothing but, suppose if I have it as a comma b in this case. So in this a comma b I take the point here x1 and x2. So when do you say that it is said to be increasing actually here? If your x1 is said to be less than x2, x1 is said to be less than x2 here, then in that case your f of x1 is also less than f of x2. Then in that case what can I say here? It is said to be increasing. Or in other words, if I say that if your x2 is greater than x1 and if your f of x2 is said to be greater than f of x1, it is automatically like that only here. For example, okay, so here in this case if you see, if this is greater than this, then you say that f of x2 is also greater than f of x1. Then you say that f is said to be increasing. Okay, so here it is said to be an increasing function. This is what you have here. This is the definition I have written here. So a function f of x is said to be an increasing in a comma b, that is in the closed interval a comma b, if as x increases f of x also increases here. That is for every alpha comma beta. Here I have taken it as x1 and x2 here. Belonging to a comma b, alpha is said to be greater than b. See how I have taken here. If your x2 is said to be greater than x1, then f of alpha is said to be greater than f of beta. In other words, I can also say that if alpha is less than b, I can also say that f of alpha is less than f of beta. Correct? Now your decreasing function is nothing but the other way around, that is the opposite of it. So the opposite of it is what actually here? Suppose if your x1 is said to be less than x2, okay, if x1 is less than x2, in that case if your f of x1 is greater than f of x2, then you say that your f is said to be decreasing. That is what I have written here. A function f of x is said to be a decreasing function in the closed interval a comma b if as x increases f of x decreases, that is if alpha comma beta belongs to a comma b. See, I have explained with x1 comma x2, but I have taken it as alpha and beta, both are the same, only here the alphabets or notation alone I have changed here, that's all. Okay, and your alpha is said to be greater than b, then you say that f of alpha is said to be f of beta. Got it? So here this is just the definition here. So if a problem is given, how do you go about it, and why does this come under application of derivatives? That is the next question you have actually here. So in order to show that if it is increasing, last exercise itself we saw, if the rate of change is said to be increasing, what did we say? Your dx by dt was nothing but positive we saw, or dy by dx was positive. If it was decreasing, what did we say actually here? Your dx by dt is nothing but decreasing we saw, that's nothing but minus sign we had actually here. The same way concept I apply here. If a function, if this f of x is said to be increasing, okay, then I can say that your f dash of x must be greater than 0, that is it must be positive. If the rate of change is positive or greater than 0, I can say that it is strictly increasing. Otherwise we say that it is strictly decreasing. So here for the problems we have an algorithm, that is the steps to be followed here. So if we follow these steps, it's easy for us to show that whether a function is said to be increasing or decreasing. So what are the steps you see here? Consider the function y is equal to f of x. Okay, that is here y equal to f of x. The first step is to find out f dash of x. The second step is to equate it to 0 and solve it and find the critical points. Okay, that is your second step. The third step is to substitute those critical points in f dash of x, and if your f dash of x is greater than 0, you say that f of x is increasing. And for the value of x, for the critical points, if your f dash of x is greater than 0, then you say that your f of x is said to be decreasing. So here these are the three steps to be followed in order to show that a function is said to be increasing or decreasing. Okay, so based on this concept we'll go over to exercise 6.2. Exercise 6.2, the first question, show that the function given by f of x is equal to 3x plus 17 is said to be strictly increasing in R. It is given here. So what is your f of x equal to here? 3x plus 17. What is your f dash of x? It is equal to 3, because when you differentiate it, what will you get? It is 3. So here in this case, your f dash of x is nothing but greater than 0. So I can say that it is said to be strictly increasing in R. Okay, according to the algorithm I gave you, if your rate of change or your derivative is greater than 0, then I can say that it is said to be strictly increasing in R. Okay. Now here the second question. So what's the second question given here? It's an exponential one. Show that the function given by f of x is equal to e power 2x is strictly increasing on R. That is given to us actually here. So I'll have to show that it is strictly increasing on the set of real numbers. So if it is strictly increasing on the set of real numbers, means x can be negative, x can be 0, as well as x can be positive. Anything it can be actually. Here my x is not defined in this case. It's nothing but a set of all real numbers. That's all. Okay. Now here we'll just write the function is said to be given by f of x is equal to e power 2x. So what is your f dash of x equal to here? It's nothing but e power 2x into 2 you get here. So e power 2x into 2 is nothing but 2 e power 2x. Okay. So I need to know whether this is said to be positive or not. That is whether this is said to be greater than 0. So how will you find that whether this is greater than 0? How is it I can find out actually here in this case? Whether it is said to be greater than 0 or not. So for that, what I do here is I split it as 3 parts, because x can be negative because they are in the set of real numbers here. X can be 0 as well as x can be positive. So how I have taken here is when x is greater than 0, that is your first case. What is your f dash of x equal to? 2 into, you know what is your e power x expansion here? It is equal to 1 plus x by 1 factorial plus x squared by 2 factorial plus x cube by 3 factorial, etc. It goes on. This is the series you get here. So according to this series, how do I write? 2 into 1 plus 2x divided by 1 factorial plus 2x the whole square divided by 2 factorial plus etc. It goes on. Okay. Now here if you see in this case, this for all values of x, for x greater than 0. For example, if you take x is equal to 2, what will you get? You will get a value which is greater than 0 only. So I can say that it is said to be strictly increasing when x is said to be greater than 0. Okay. Now the second case, what's the second case you get here? When x is equal to 0. So when x is equal to 0, what is your f dash of x equal to? Actually your f dash of x is equal to 2 e power 2x. So when x is equal to 0, when I substitute it, what will I get? 2 e power 0. What is e power 0? That's nothing but 1, which is equal to 2, and that is said to be greater than 0 you get. Got it? So here in this case, this is also increasing. So here when it is, when you see here, it is said to be increasing for x is equal to 0 also. Now the last case is when x is negative, that is when x is less than 0. So when x is less than 0 means what is it? X will take negative values, that is x will be minus 1 or minus 2 or minus 3. So what I do here is I replace by x by minus x here. So when you replace it, what will you get? 2 e power minus 2x. How can I write this as? 2 by e power 2x you can write here, which is equal to 2 divided by, again this e power 2x is nothing but 1 plus 2x plus 2x by 2 the whole squared. Okay, 2x the whole square divided by 2 factorial plus etc. It goes on. So here again, for all values of x, whatever you take in this case, it will be greater than 0. So for all the 3 cases, they are said to be greater than 0. Therefore, finally, how can I conclude here? Your f dash of x is greater than 0 and your f of x is increasing on the set of real numbers. Okay, so here if you see, it is said to be increasing in the set of real numbers. Got it? So here in this case, since the interval is not specified, they have given us our real numbers. That's why I take it as 3 cases. If the interval is specified, you can take the interval alone and show at which part it is said to be increasing or decreasing. Correct? Third question, show that the function given by f of x is equal to sin x is strictly increasing in 0, pi by 2 and strictly decreasing in pi by 2, pi, and neither increasing nor decreasing in 0, pi. Okay. So the first one we saw was an algebraic one. The second question was exponential. Here if you see, it's a trigonometric one. So what is given to us actually here? F of x is equal to sin x. So what's the first step I told you here? You will have to find out whether what is your f dash of x. What is your f dash of x equal to here? F dash of x is equal to cos x. Okay, so now before checking whether it is said to be positive or negative in the interval here, in the given interval, I'll just brush through a basic topic what you have studied in your 11th standard here under trigonometric functions. You all would have studied here. It is 0, pi by 2, pi, okay, and here again if you see it as 3 pi by 2, and here again if you see this is nothing but 2 pi. I can also have it as 2 pi in this case. So here in this case, in the first quadrant, all the trigonometric functions are positive, you know here. In this case, your sine function alone is positive, the remaining are negative, all silver teacups. In this case, your trigonometric function alone is positive, and here if you see, your cosine function alone is positive. The remaining functions are all negative in this in the respective quadrants here. Okay, the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So I am going to make use of this part only here. Okay, so here if you see, your f dash of x is equal to cos x. I say that it is greater in the interval 0, pi by 2. Why do I say that it is greater than 0 or positive in the interval 0, pi by 2 here? So in the quadrant 0 to pi by 2, all trigonometric functions are positive. So if all trigonometric functions are positive, what can I say here? Your cos x is greater than 0. That is what you have here. In other words, you can also check. So if I take cos 0, that is nothing but equal to 1. What is cos pi by 2? That is nothing but 0. So here again I can say that it is said to be positive by saying like that also. But here I have taken the quadrants part actually here. This is how you say. So all the trigonometric functions in the quadrant 0 to pi by 2, they are said to be positive. Therefore, I say that f is said to be strictly increasing in 0, pi by 2. Correct? Now your b. Okay, b again, we will take f dash of x is equal to cos x. What is the next interval you have here? Pi by 2 to pi. So in the interval pi by 2 to pi, except sine, all the other trigonometric functions are negative. So what is the trigonometric function you have here? Cos x. So what is cos x here? It's nothing but less than 0. So cos x is less than 0 means in the interval pi by 2, pi. Therefore, what can I say? F is strictly decreasing in the interval pi by 2, pi. This is what you have here. Correct? So your f dash of x is equal to cos x. Your cos x is less than 0, I say, because in the interval pi by 2, pi, that is in the second quadrant, if you see, your sine is said to be positive, but all the other trigonometric functions are negative. Therefore, you say that cos x is less than 0. Thus, you say f is said to be strictly decreasing in the interval pi by 2, pi. Got it? Now here, your third one, C. F dash of x is equal to cos x you have here. So f dash of x is equal to cos x. Okay, neither increasing nor decreasing in the interval 0, p. That is what you have here. Now, this 0, pi, we will split it as 0, pi by 2, and the other one is pi by 2, pi. This is how I split. Now, you know that in the interval 0, pi by 2, it is increasing. In the interval pi by 2, pi, it is said to be decreasing. Okay. So, if in this part it is increasing and in this part it is decreasing, what will I say here? F is said to be neither increasing nor decreasing in the interval 0, pi, because in one case it is increasing. Okay. When you take the interval 0 to pi, you take here. So, I will take pi by 2 here. In this case, if you see, it is increasing. In this case, if you see, it is increasing. So, there is a fluctuation here. Therefore, you say that it is neither increasing nor decreasing in the interval 0, pi. Is it clear? So, a very simple concept. Only thing is what you must be aware of this one here, the trigonometric functions here, and it's clearly you can write that it is said to be increasing or not. Okay, it can be asked in a multiple choice question. Such questions can be asked. Check whether it is said to be increasing or decreasing in which interval. Got it? Yes. Now here your fourth question. So what's the fourth question you get here? find the intervals in which the function f is said to be given by f of x is equal to 2x squared minus 3x is strictly increasing and it is said to be strictly decreasing. This is what you have here, okay. F is said to be strictly increasing and f is said to be strictly decreasing. So it's an algebraic one here. So as usual, what's the first step I told you here? Your f of x is equal to 2x squared minus 3x. What is your f dash of x equal to 4x minus 3? Got it? Now, what is your second step? Equate it to 0. So, when I equate it to 0, what will you get? 4x minus 3 is equal to 0. So, 4x minus 3 is equal to 0 means what will you get? X is equal to 3 by 4. Got it? Now, I just draw a real line here. You've got 0 in the center, 3 by 4 here. In this case, the interval is from minus infinity to infinity. Now, we'll just split the intervals in this case. Okay, first I take it as minus infinity to 3 by 4. So here in this case minus infinity to 3 by 4, I need to check whether your f dash of x is said to be increasing or decreasing. That is whether it is said to be less than 0 or greater than 0. So in this interval, what is that you do here? You take any negative value here. For example, I take minus 1. When I take minus 1 and substitute it here, what will I get? Minus 4 minus 3, that is equal to minus 7 you get. So what happens in this case actually here, your f dash of x is said to be less than 0. Okay. Next, what's the next interval you get here? 3 by 4 to infinity. So what is it you have here? 3 by 4 to infinity you have here. So in the interval 3 by 4 to infinity, again I'll just take it as plus 1 we take, okay, because it's only plus 1 here. When I substitute it, what will I get? 4 into 1, okay, so here it's nothing but 4 into 1 minus 3. What is it equal to here? It is equal to plus 1. So what can I say in this case actually here? Your f dash of x is said to be greater than 0. You understood how to be checked in this case actually here? Just take any random values between this interval, substitute in this. You can do it in the rough column here. You just substitute and check whether it is less than 0 or it is greater than 0. So if it is less than 0, what can I say here? It is said to be increasing, it is said to be decreasing in the interval minus infinity to 3 by 4, and if it is greater than 0, I say that it is increasing in the interval 3 by 4 to infinity. So how I write my conclusion here? My conclusion is written as in minus infinity comma minus 3 by 4, your f dash of x is less than 0 and f of x is said to be strictly decreasing in minus infinity comma minus 3 by 4, because they have asked us for the intervals where it is said to be increasing and where it is decreasing. Okay. Now the next one is what? In the interval 3 by 4 comma infinity, your f dash of x is greater than 0. Therefore, your f of x is said to be strictly increasing in 3 by 4 comma infinity. Understood? So I think it's a very easy one. I hope you have understood. So based on this concept only, we will be having all the questions throughout this exercise mostly. Okay. Now the fifth one. What's the fifth one you get? Find the intervals in which the function f is said to be given by f of x is equal to 2x cube minus 3x squared minus 36x plus 7 is said to be strictly increasing and strictly decreasing. So I need to find out at which interval the function is said to be increasing and which interval the function is said to be decreasing. So for that, first step is what actually here? You will have to differentiate it. I have written the question here. Given f of x is equal to 2x cube minus 3x squared minus 36x plus 7 you get here. So your f dash of x is equal to 6x squared minus 6x minus 36 you get. Now to find the critical points, your second step. What's the second step you have here? Equate it to 0. F dash of x is equal to 0. So when I equate it to 0, what will I get here? Your 6x squared minus 6x minus 36 is equal to 0. So here when I divide it, you will get it as x squared minus x minus 6 is equal to 0 you get here. In other words, you can write it as x minus 3 into x plus 2 is equal to 0 when you factorize this. So you will get x is equal to 3 and x is equal to minus 2. Okay. So I'll write my f dash of x as 6 into x minus 3 into x plus 2. Got it? So I've just drawn the number line here, plotted the points. It's minus 2. You've got another point 3 and this is minus infinity to infinity. So how is it I take my intervals here? One interval is minus infinity to minus 2. The other interval is minus 2 to 3. What's the third interval you get here? 3 to infinity. This is what you have here. Okay. Now you will have to check in all the intervals. Minus infinity to minus 2. So minus infinity to minus 2. What can we do? Can we take a negative value in this case actually here? Yes, I'll just take it as minus 3. When you substitute minus 3 here, what will you get? You will get a negative value. When you substitute minus 3 here also, minus 3 plus 2 is what? Minus 1. So you will get it as minus. Minus into minus is what actually here? It's nothing but plus. So what happens actually here in the interval? Okay, so here in minus infinity comma minus 2, what do I say? My f dash of x is said to be greater than 0. Got it? So here, just take any value here between the interval minus infinity to minus 2 here. So your f dash of x is greater than 0. So what can I say? F of x is strictly increasing in minus infinity comma minus 2. Next is what? Take the next interval minus 2 to minus 3. So in the interval minus 2 to minus 3, maybe I'll take plus 2 here. Can I take plus 2? So when I take plus 2, what will happen actually here? 2 minus 3. What is 2 minus 3? That's negative. 2 plus 2. What is it? It's positive. Minus into plus is what? Negative. So what do I say here? In the interval minus 2 comma 3, your f dash of x is said to be less than 0. Correct? It's less than 0. Therefore, your f of x is said to be strictly decreasing in minus 2 comma 3. This is what you have here. Now, what's the next one you have here? The last interval in 3 comma infinity. So, what is it in the interval 3 comma infinity? Suppose you take it as 4 here. So, when I take 4, 4 minus 3 is nothing but 1 into 4 plus 2 is what? 6. So, positive into positive will be what? Positive. Therefore, what can I say here? Your f dash of x is greater than 0. Therefore, f of x is strictly increasing in the interval 3 comma infinity. Got it? So, here how do I write my conclusion in this case? Your f of x is strictly increasing in minus infinity comma minus 2 union 3 comma infinity. That is how I have written here. And f of x is strictly decreasing in the interval minus 2 comma 3. That's how you say that it is said to be increasing in the intervals in this case. Is it clear to all of you? Yes? The sixth question. So find the interval in which the following functions are strictly increasing or decreasing. Okay, so here if you see, I'll have to see whether it is said to be strictly increasing or decreasing here. So what's the function given here? F of x is equal to 10 minus 6x minus 2x squared you've got. So here find out what is f dash of x, your first step. So here f dash of x is equal to differentiation of 10 will give you what? 0. Minus 6x when you differentiate it's minus 6 minus what will you get? It's minus 4x. Now equate this to 0. F dash of x is equal to 0. So what will you have? Minus 6 minus 4x is equal to 0 you get. So what is minus 6 equal to here? Minus 6 is equal to 4x, which implies your x is equal to minus 3 by 2. Correct? Now here if you see, I have just drawn the interval in this case actually here. So what is the interval you have here actually here? Your interval, it's minus infinity to minus 3 by 2 and minus 3 by 2 to infinity. Now we'll just take a value here in the interval minus infinity to minus 3 by 2. So can I take it as minus 2 in this case actually here? So when I take it as minus 2, substitute it in this f dash of x. What will I get? Minus 6 minus 4 into minus 2 will be what? 8. 8 minus 6 is nothing but plus 2. It is greater than 0. So what have I written here? In the interval minus infinity comma minus 3 by 2, your f dash of x is said to be greater than 0. Correct? So I can say that f of x is said to be strictly increasing in the interval minus infinity comma minus 3 by 2. Correct? Now here the next one. What's the next one you get? In minus 3 by 2 to infinity. So in the interval minus 3 by 2 to infinity, what do I do here? I'll just take one positive value. Maybe I'll take it as plus 2 here. So when I take plus 2, what will happen? It's minus 6 minus 8 because 4 into 2 is nothing but 8 here. So it's minus 14. So here if you see it is nothing but less than 0 you get. So f dash of x is said to be less than 0. Therefore what can I say? F of x is said to be strictly decreasing in the interval minus 3 by 2 comma infinity. This is what you have here. Correct? Okay, so here just 3 steps here. First step, second step and then the third step here. I'm not you need not write those values or whatever it is. It's enough if you write whether it is greater than 0 or less than 0, and you can proceed by saying whether it is increasing or decreasing. Okay, so under the sixth question, E subdivision. Okay, again I'll have to find out the intervals at which the function are said to be decreasing or increasing here. So x plus 1 the whole cube into x minus 3 the whole cube. So I have just named it as f of x is equal to x plus 1 the whole cube into x minus 3 the whole cube. Now I'll have to differentiate it with respect to x. How can I differentiate it with respect to x in this case? Actually here I'll have to use the uv formula. So what is the uv formula? D by dx of u into v is equal to u into dv by dx plus v into du by dx. This is the formula you have here. So u into dv by dx plus v into du by dx. Now when I differentiate it, what will I have? X plus 1 the whole cube into differentiation of this one. What will I get? 3 into x minus 3 the whole squared plus what will I have? X minus 3 the whole cube into differentiation of this is what? Differentiation of x power n is what? N x power n minus 1. So it is 3 into x plus 1 the whole squared. Now I can take common actually. What are the terms I can take common here? 3 can be taken common. X minus 3 the whole squared can be taken common, and x plus 1 the whole squared can be taken common. So I have written it as 3 into x plus 1 the whole squared into x minus 3 the whole squared. So you are left with x plus 1 plus x minus 3 you get. So here you get it as 2x minus 2 here. So again when you take this 2 common here, you are left with 6 into x plus 1 the whole squared into x minus 3 into x minus 1. This is what you get here. Now we will find the critical points here. So when I find the critical points is what is step 2. F dash of x is equal to 0. When I equate it, 6 into x plus 1 the whole squared into x minus 3, okay, the whole squared you get here, into x minus 1 is equal to 0. So you get x is equal to minus 1, x is equal to 3 and x is equal to 1, equating it to 0. So I have just drawn it in the real, plotted it here, minus infinity to plus infinity, minus 1 plus 1 and then you have 3. Just plotted the critical points alone here. So what are the intervals you will get here? Minus infinity to minus 1, minus 1 to 1. What's the next one here? 1 to 3, and what is the next one you get here? 3 to infinity. This is how you get here. Now we will see in all the 3 intervals here. It's minus infinity to minus 1. So in the interval minus infinity to minus 1, suppose what is that I can take here? I can take it as minus 2. So when I take minus 2, what will you have here? Because it's the whole squared, whether it is negative or positive, whatever it is, it will be only positive. Again here if you see in this case also it will be positive. When I substitute minus 2 minus 1, you will get it as a negative 1 here. So plus into minus is what? Minus. So it's nothing but it is said to be less than 0. Therefore what can I say? F of x is decreasing in the interval minus infinity comma minus 1. Got it? Now here what have you got? Minus infinity to plus 1. So what is minus infinity to plus 1? Maybe I can take it as 0. So when I take 0 here, your f dash of x, again I told you, if you have anything whole squared, it will be positive, because when you square that term, you will get only positive values. So the first 2 problem, no problem here. Plus into plus only you will get. So it is plus into plus. Here 0 minus 1 is what? Minus here. So what will you get? It's negative. It is said to be less than 0. So what will I write? Your f of x is decreasing in the interval minus 1 comma 1. Got it? Now the next one. What's the next one you get here? 1 comma 3. So what is your 1 comma 3 here? Your f of x is equal to, or your f dash of x is equal to, what will I have here? In 1 comma 3, maybe I can take it as 2. As I told you earlier, this is also positive, this is also positive. No confusion about it. 2 minus 1 is what? Again it's only plus 1, so it's only positive here. Plus into plus into plus, what will you get? It's nothing but positive. So what can I say? It is greater than 0. So if it is greater than 0, what is that you have here? Your f of x is increasing in the interval 1 comma 3. This is what you get here. Okay. Now the next one, in the interval 3 comma infinity. So what is it? In the interval 3 comma infinity, suppose I have it as 4. Okay. So what is your f dash of x equal to here? 4, this is positive, again 4 minus 1 will give you what, 3. So that is also positive. So positive into positive into positive, that is also positive. It is greater than 0. Therefore, f of x is increasing in the interval 3 comma infinity. So how do I write my conclusion here? F of x is strictly increasing in 1 comma 3. Okay, so here in this case actually it is increasing in 1 comma 3 union 3 comma infinity. Now f of x is strictly decreasing in minus infinity comma minus 1 union, what will I get here, minus 1 comma 1. Correct? The next question, show that y is equal to log of 1 plus x minus 2x divided by x plus 2 for x greater than minus 1 is said to be an increasing function of x throughout its domain. Okay, so what is given here? Your function f of x is equal to log of 1 plus x minus 2x divided by x plus 2 is given to us. Okay, now you will have to differentiate it with respect to x here. So when you differentiate it with respect to x here, that's your first step. So differentiating it with respect to x, your f dash of x is equal to, you know what is differentiation of log x, that's nothing but 1 by x. So you have it as 1 by 1 plus x minus, here again I'll have to use the u by v formula. So when I use a u by v formula, what will I get? It's d by dx of u by v is equal to v into du by dx minus u into dv by dx divided by, what will I have here? It's nothing but v square. This is what you have here, correct? So it's 1 by 1 plus x minus 2 into, I've used a u by v formula, taking this 2 outside, you're left with, it's the v into, v is nothing but x plus 2 into differentiation of x, that's nothing but 1 minus x into, okay, so that's a u here, x into differentiation of the denominator. So what is differentiation of the denominator here? That's also nothing but 1 divided by x plus 2 the whole squared. So here it is equal to 1 by 1 plus x minus 2 into, here it is x plus 2 minus x divided by x plus 2 the whole square. So your x and minus x gets cancelled. It is 1 by 1 plus x minus 4 divided by x plus 2 the whole square. Now I'll have to take the LCM of the denominator here. When you take the LCM of the denominator, what will you get? It's x plus 1 into x plus 2 the whole square. Cross multiplying, you will have it as x plus 2 the whole square minus 4 into x plus 1. So here a plus b the whole squared is what? X square plus 4x plus 4 minus 4x minus 4 you get. So here plus 4 and minus 4 gets cancelled, plus 4x and minus 4x gets cancelled. So you are left with x square divided by x plus 1 into x plus 2 the whole squared. Correct? Yes. Now for us in the question it's clearly given that when x is said to be greater than minus 1, the interval is given here. So when x is greater than minus 1, what is the interval here? In this case it is in the interval minus 1 comma infinity. So when I take it as minus 1 comma infinity, if I put minus 1 here, you will get it as infinity in this case. Something divided by 0 will give you what? Infinity. So omitting that, we will just take only these function here. So it is x square divided by x plus 2 the whole square. So here whatever value beyond minus 1, if I substitute, since it is square of it, it's x square divided by x plus 2 the whole square. It's going to be greater than 0 only in this case. Okay, so here since it is greater than x squared by x plus 2 the whole square, that is only nothing but greater than 0. Therefore, what can I write here? Your f dash of x is nothing but greater than 0. Correct? So f dash of x is greater than 0, and therefore what can you say? Your f is said to be increasing in x greater than minus 1. Okay, so here in this case clearly they have mentioned in the question itself, okay, in the interval x greater than minus 1, I will have to check whether it is said to be an increasing function or not throughout in the domain here. So here in this case, since it is x greater than minus 1, if I write this, it's not applicable because something divided by 0 will give me only infinity here. That's the reason we have it as x squared by x plus 2 the whole squared. When I substitute anything, it will be only positive because you have the numerator is also square, the denominator is also a square. Therefore, f dash of x is greater than 0, and thus you say that f is increasing in the interval x greater than minus 1. Got it? Yes. Now, the 8th question here. So, what's the 8th question? Find the value of x for which y equal to x into x minus 2 the whole squared is said to be an increasing function. Okay. Now here as usual just give it a name to us f of x is equal to. So here I'll just multiply it, it's x squared minus 2x the whole squared you have here. Now what's the first step? Differentiate it with respect to x. So when you differentiate it, you will have it as f dash of x is equal to 2 into x squared minus 2x into differentiation. Remember the chain rule here. So here 2 into x squared minus 2x into differentiation of this will give me what? 2x minus 2. Now you can take 2 common here, and from this I can take x common. So you are left with 2 into 2 is what? 4. Here you have it as x. So 4x into x minus 2 into x minus 1. Okay. Now what's the next step? To find the critical points. Critical points are f of x is equal to 4x into x minus 2 into x minus 1. So when you equate it, you will get it as x is equal to 0, x is equal to 1 and x is equal to 2. So this is the real line you get here. It is 0, here you have 1, here you have 2, here it's minus infinity to plus infinity. This is what you have here. Now as I told you, it's x into x minus 2 into x minus 1. So how many intervals are there? Okay, this is one interval, this is one interval, this is one interval, and what's the other interval you have? This is the other interval. So now already I've told you how to check. So in the interval minus infinity to 0. So in the interval minus infinity to 0, what will you get here? Minus infinity to 0, it's nothing but minus 1. So in the interval minus infinity to 0, you have it as minus 1 here. So when I substitute minus 1 here, it will be minus. Here again it will be nothing but minus you will have here. Here again if you see, it's nothing but again minus. This is what you have here when I substitute minus 1. Got it? So minus into minus is nothing but plus. Plus into minus is nothing but negative is what you have here. So what have I written here? Your f dash of x is said to be less than 0. Therefore what can I say? F of x is strictly increasing in the interval minus infinity comma 0. Correct? Now the next one, minus 1 comma 0. That's a next one you have here. So in the interval, 0 comma 1. So the interval 0 comma 1. So between 0 and 1, if I take any one value, maybe I can take it as 0.5 or something like that. So if I take it, what will I have here in the interval 0 comma 1? Here you will have positive, here it is negative, here again it is negative. This is what you have here. So minus into minus it's plus, plus into plus is nothing but plus. So it is greater than 0. That's why I have written f dash of x is nothing but greater than 0. And therefore it is strictly increasing in the interval 0 comma 1. Correct? Now the next one, what's the next one you have here? Between the interval 1 and 2. So between the interval 1 and 2, it's nothing but 1.5 you have here. So in the interval 1 and 2, it's 1.5. So when I substitute it here, it is plus 1.5, it is plus here. 1.5 minus here again, what will I get here? It's minus 1.5 minus 1, that will give you nothing but plus. So plus into minus is minus, minus into plus is minus. Therefore you get f dash of x is less than 0. Therefore what will I say? F of x is strictly decreasing in 1 comma 2. Correct? Next is what? 2 to infinity. 2 to infinity, can we take 3? When I take 3, when I substitute it here, you will have plus. 3 minus 2 is nothing but 1. So it is plus here. 3 minus 2, that is also nothing but plus. Okay. So plus into plus into plus, that's nothing but greater than 0. Therefore f dash of x is greater than 0. That's you say that f of x is strictly increasing in the interval 2 comma infinity. Correct? Yes. Now the next one here, okay, it's a trigonometric one. Prove that y is equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function on the interval 0 comma pi by 2. So the interval is given to us. I'll have to check whether it is said to be increasing or not. Okay. So here you have got dy, y is equal to 4 sin theta divided by 2 plus cos theta minus theta you get. Now we'll differentiate it with respect to theta. Your first step, how will I differentiate it? I'll have to use a u by v formula. So what is your u by v formula? D by dx of u by v is equal to v into du by dx minus u into dv by dx divided by, what will I have here? It's nothing but v square. This is what you have here. Now differentiating it with respect to theta, what will you get? Dy by d theta is equal to, it is v. V is nothing but 2 plus cos theta into differentiation of the numerator, that's nothing but 4 cos theta minus 4 sin theta into differentiation of the denominator. What is differentiation of 2? That's nothing but 0. Differentiation of cos theta is nothing but minus sin theta divided by 2 plus cos theta the whole squared minus 1. This is what you have here. Okay, it's nothing but minus 1. Now we'll just simplify it here. When I multiply it, what will I have here? It's 8 cos theta plus 4 cos square theta minus into minus, it's plus 4 sin square theta divided by 2 plus cos theta the whole squared minus 1. This is what you have here. Now what's the next step you get? 8 cos theta plus 4 into cos square theta plus sin square theta divided by 2 plus cos theta the whole squared minus 1. So what will I have here? It's nothing but 8 cos theta plus 4 divided by 2 plus cos theta the whole squared minus 1. This is what you have here. So I have simplified it here. Now I need to check whether in this interval 0, pi by 2 it is said to be positive or not. Okay. So here the next step, 8 cos theta plus 4. Okay, so here cross multiplying you will have it as minus of 2 plus cos theta the whole squared divided by 2 plus cos theta the whole squared you get. So it is 8 cos theta plus 4 a plus b the whole squared. So it's a squared. You have the minus sign here, so it becomes negative throughout. It's minus 4 cos theta minus 2ab plus b squared. So plus into minus is nothing but minus. So it's minus cos square theta divided by 2 plus cos theta the whole square. So your plus 4 and minus 4 it gets cancelled. So 8 cos theta minus 4 cos theta is what? 4 cos theta minus cos square theta. So here it is equal to cos theta into 4 minus cos theta divided by 2 plus cos theta the whole squared. Okay. Now we will check whether this function is said to be greater than 0 in the interval 0, pi by 2. Okay. You know that cos is increasing. How do I say that cos is increasing in the interval 0, pi by 2? I already told you. What is it here? 0, pi by 2 in this case, all silver teacups I told you here. So in this interval 0, pi by 2, all the trigonometric functions are positive. So your cos theta is greater than or equal to 0. So if next is what? 4 minus cos theta is greater than 0 means what do you mean by that? Your 4 is greater than cos theta. So in that case what can I say? Your 4 minus cos theta is also greater than 0 because utmost value cos pi by 2 is what? It is equal to 1. That's all. So for sure this also will be greater than 0. So this is greater than 0. This is greater than 0. What can you say about the denominator? Already I told you anything the whole square, this also will be greater than 0. So numerator is also positive, the denominator is also positive. Therefore what can I say here? Your cos theta into 4 minus cos theta divided by 2 plus cos theta the whole square is also greater than 0 in this case. Okay, therefore your dy by d theta is greater than or equal to 0. Therefore your function is increasing in the interval 0, pi by 2. Correct? So here you need not worry by seeing it's a trigonometric function, it's very difficult. Just go step by step in this case actually. If you have to find the critical points and find the critical points, in this case an interval is given to you. So that critical point is not needed for you here. You will have to just find out if in that interval 0, pi by 2 it is said to be increasing or not. Okay, if it's a trigonometric, just remember this concept alone here. Okay, now the 11th one. What's the 11th one you have? Prove that the function f is said to be given by f of x is equal to x squared minus x plus 1 is neither increasing nor decreasing strictly on minus 1, 1. Okay, so here you have your f of x is equal to x squared minus x plus 1. What's your f dash of x? It is equal to 2x minus 1. F dash of x is equal to 0 means you will get 2x minus 1 is equal to 0. Therefore your x is equal to 1 by 2. So again here the interval is minus 1 to 1. It's not on the real line R. So how is it I will break my interval here? Minus 1 to 1. In between what is the critical point you have here? It is 1 by 2. So what is the interval you have? Minus 1 to 1 by 2. Here if you say it's 1 by 2 to 1. This is how you get here. So in the interval minus 1 to 1 by 2. So between this interval minus 1 to 1 by 2, what is that you will have here? You can have the interval 0 here. So when I substitute it, 0 minus 1 is nothing but minus 1. So it is less than 0. So it is decreasing in the interval minus 1 by 1 by 2. Now in the interval 1 by 2 to 1. So in the interval 1 by 2 to 1, you can take any value here. It will be only greater than 0. You can just check it. Therefore, it's strictly increasing. So, in the interval minus 1 to 1, this part if you see here, it is decreasing, and this part if you see here, it's increasing. Therefore, what can I say here? F of x in the interval minus 1 to 1, it's neither increasing nor decreasing on the interval minus 1 comma 1. So, whenever a question is given, read the question carefully, whether it is on the set of real numbers or in the interval minus 1 comma 1. Or you will have to find the critical points actually. So, these are the three different types which can be asked under this exercise. 14 question. Find the least value of a such that the function f is said to be given by f of x is equal to x squared plus ax plus 1 is said to be strictly increasing on the interval 1 comma 2 it is given here. So, your f of x is equal to x squared plus ax plus 1. It is said to be strictly increasing means you know that your f dash of x is said to be greater than 0. And one more thing, I can also say that your f of 1 will be nothing but less than f of 2. Okay, so here that's how you have here. Okay, f of 1 is said to be less than f of 2. So, here in this interval 1 comma 2, I have written it as 1 less than x less than 2. Okay. So, here I will just simplify it a little and write here. This when I multiply by 2, you will have it as 2 less than 2x plus 4 in order to bring it to this function so that I can say it lies between what and what here. So, when I add both sides, what will I get? 2 plus a is less than 2x plus a less than 4 plus a. This is what you have here. Therefore, f of x is said to be a strictly increasing function. So, if it is said to be a strictly increasing function, what can I say here? This 2 plus a is nothing but greater than 0. Of course, this is also greater than 0, but I want the least value in this case. So, if 2 plus a is said to be greater than 0 in this case actually here, so what will I get? A is said to be greater than minus 2. Therefore, what is the least value of a you have here? The least value of a is nothing but equal to minus 2. Got it? So, again it's only a 2-mark question here. How do you find out the least value? If it's said to be strictly increasing or strictly decreasing. Okay. Now, your 16th question. What is the 16th question? Prove that the function f is said to be given by f of x is equal to log of sin x is said to be strictly increasing on 0 comma pi by 2 and strictly decreasing on pi by 2 comma pi. So, already we have done so many trigonometric questions here the same way. Okay. So, here as usual just remember this rule here 0 pi by 2 it's pi. Here again it is 3 pi by 2 and here you have got 2 pi. Here all silver tea cups I told you here. Okay. So, all trigonometric functions positive, sine is positive, tan is positive here and cosine is positive here. Okay. So, remember if sine and its allied function, what's our next one here? Cosecant. If it is tan, cot is also positive here. It is cosine, secant is also positive here. Now, given f of x is equal to log of sin x. So, when I differentiate it, what will I get? By using chain rule, f dash of x is equal to 1 by sin x into differentiation of sin x will give me what? Cos x. Cos x by sin x is nothing but equal to cot x you will have here. Now, in the interval 0 to pi by 2. So, in the interval 0 to pi by 2, all the trigonometric functions are positive. That is cot x is also positive. So, cot x is greater than 0. I can say that f of x is increasing in the interval 0 comma pi by 2. Next is what? In the interval pi by 2 comma pi by pi. So, in the interval pi by 2 to pi, only your sine and cosecant are positive. Okay, all the other trigonometric functions are negative. So, what will I write? F dash of x is equal to cot x, which is said to be less than 0. Therefore, f of x is strictly decreasing in pi by 2 comma pi here. So, here by the question we have proved that f of x is said to be strictly increasing in the interval 0 comma pi by 2 and it is decreasing in the interval pi by 2 comma pi. Got it? Yes. Now, the next one. Prove that the function given by f of x is equal to x cube minus 3x square plus 3x minus 100 is increasing in R. So, what is your f dash of x equal to? F dash of x is equal to 3x squared minus 6x plus 3. Okay, so here it is equal to 3 into this one. I can write it as 3 into x minus 1 the whole square. So, it is increasing in the real interval. So, in the real line. So, if it's in the real line, it takes all positive, 0, negative numbers, everything. So, here if you see, already I told you, if it is the whole squared, whatever may be your x value, it will be only positive, that it will be only greater than 0. Therefore, what can I say here? Your f of x is said to be increasing in R. Got it? So, here This is your exercise 6.2. So questions from this part can be asked for 2 marks as well as for 4 marks here. So be clear with what is an increasing function. I told you the algorithm in the beginning of this lesson here, that is your exercise 6.2. So just go by the algorithm here. As I told you earlier, there are 3 types here. One is the interval can be given to you, otherwise it can be a real line, otherwise you will have to find out what is the trigonometric function, the critical points there, and then you will have to check whether it is said to be increasing or not.